Hello, my name is Sharunas and I am from Direct Machining Control. I will not pause much during the talk due to the time limit, but since it is a recording, I hope you can pause anytime to explore the data. So let's dive in. At first, a bit about us. DMC was started in 2014. We are based in Vilnius and we come from the laser micromachining background. What we do is the software for the laser machine control, which takes care of all the steps from CAD import to getting the final part. It is also hardware independent and covers a wide range of applications. Now about the experiment. We compared 4 different technologies that combine stage and galvo scanner motion. Since all of these technologies are used in an electronics production, we compared the production efficiency and accuracy depending on the technology, trajectory type, density, and cutting speed. All the tests were done on the same hardware setup controlled by DMC. Based on the results, at the end of the presentation, we are providing recommendations on which technology is best in which case. The experimental setup consisted of XYZ stages controlled by ACS, galvo scanner from ScanLab with RTC6 and a camera. All this was controlled and calibrated by DMC software. The recipe we used within the DMC was simply a stitching command and a CAD object. For XLScan case, just a CAD object with appropriate marking parameters. The parameters that we have changed were repeats that represent density. We changed both mark and jump speeds. Laser frequency was adjusted to keep the same pulse density. Overlap was the stitching parameter, and we did this in 4 different process types. Namely, stitching, marking on the fly, adaptive marking on the fly, and XLScan. We evaluated processing time and marking quality. Processing time was calculated automatically by the software, and we also wrote a simple automated routine, as you can see here, to capture images after marking for later inspection. This is the first pattern, which contains mixed size objects. Important here is that larger objects do not fit into the galvo field. And this is the second pattern, consisting of smaller objects. Individual elements here easily fit into the galvo field. And just a note, these patterns here are taken from the electronics industry. Now about the results. First, a bit about the quality. It depends on many aspects, but system calibration is one of the most important, and it is controllable. The revelation is that using technologies like XLScan, it is much more forgiving even if we do not have the perfectly calibrated system. The quality is simply better. When using stitching and on-fly, we also noticed that having an option to define overlap helps to fix gaps due to stitching errors. This first graph depicts the process duration dependency on the marking speed and the process type for the pattern with mixed size objects, where some of them are larger than the galvo field. We clearly see that this pattern is very unfavorable to the XLScan. It uses a lot of stage motion, and increasing marking speed does not reduce the processing time much. However, XLScan gives the best quality with the least effort. Others look more even, and the adaptive mark on fly gets the best time. For the second pattern with small objects, we see a drastic change. Now the slowest process is with standard stitching. XLScan is fastest with low process speeds, but in higher speed, a more optimized adaptive mark on fly takes less time. Quality here is not an issue for all types except for traditional on fly. The next graph has a lot of things happening. Again, I encourage you to pause and explore. For this pattern with the mix of large and small objects, we see that XLScan is slow and gets slower with increasing density. But for other processes, we see that increasing speed from 500 to 2,500, it reduces the effect the density has on process time, as dense areas are dominantly taken care of by fast galvo. For the second pattern, with small features, XLScan works well. Stitching is the slowest type, and here increasing speed from 500 to 2,500, we can see again it reduces the effect of the density to processing time, and stage motion again becomes the stronger factor. Now to conclude, for the quality, the best choice is always XLScan. Its accuracy is the best. Then for processing speed, it's adaptive mark on fly. It is the most optimized to utilize a fast galvo. And for minimal cost of the setup, it is stitching technology, as you can use any stage and galvo combination plus the DMC. We also noticed that XLScan favors a more uniform pattern. Additionally, using DMC's overlap option, it helps to overcome most of the stitching errors. And we also noticed that increasing pattern density at large galvo speeds does not increase the processing time significantly, as the time is dominantly influenced by a much slower stage motion. And this can benefit to reduce the setup cost by lowering laser power and increasing repeats without losing too much on a processing time. That is it. Thank you. If you would like more details, please reach out.